Hi, I'm Jabe. I am finishing my PhD at Carnegie Mellon, and I am writing in what's called design studies. And in the field of design studies, we apply philosophy to design. I do mostly continental philosophy, so if you've seen Barry give a talk, he and I like talking about all sorts of things. But my talk today, I'm going to do some design theory. I'm going to present a particular theory that I call the Three Economies that has to do with thinking about platforms. And I'm going to talk a little bit about what I think the implications of the theory are for designing platforms. First, I think that this is, after about 10 years of playing with it, is my favorite definition that I've come up with so far of what design is. Design is the intentional formation of purposeful systems. I highlighted formation here because of the way I wanted to talk today. I'd like to point out that it is a verb. It's like an activity that's happening. It is not a form is usually kind of thought of as being static. This is not static. And just really quickly, intentional in this particular definition has to do with the way in which people take things as being something. So if I look at an apple, I take it as an apple. I have an impression that it's an apple, to the extent that if the apple is on a table in front of me and I walked around it and there was no back of the apple, I would be surprised, yes? So I take things as being certain things. So we intend towards things. We have a mental conception of how they work, and what we intend towards is not just physical things, but also ideas. So maybe this is kind of like what design is generally. Someone says, I need help with something. Can you tell me an answer? We go look at a user context. We ask about user needs. We do some expert analysis. And then we have I believe this is the answer to your question. You should do this. So the interesting thing I think about this is that it's a pretty linear view of design. And I always try to point out that this thing that we're doing will almost certainly impact the user context. And because we impact the user context, we'll probably change the user need. So in other words, the better we are at thising, suggesting what should be done, the more likely we are to need to continue making further propositions about what the design should be. In other words, what we're trying to do here is we're trying to make confident statements about what we believe will solve a problem, but we have that question mark hanging there because we're open to new information. And the reason we're open to new information is design is always evaluated in context. It cannot be evaluated outside of context. This is always evaluated in user context, and the user context is always changing. Because this modifies user context, which modulates human needs, design is in essence always open-ended. Design is an open-ended system. Another way of saying this is all design is inherently incomplete. You cannot complete designs. So that echoes Wittgenstein and Gödel, who both determined that any descriptive system, like mathematics or like language, A, is essentially incomplete, and B, can only be evaluated in context. So Wittgenstein's language games basically says language can only be evaluated in the lived situation. So, in the United States, there's lots of companies that have this model. I don't know how prominent it is here in Europe, but it is a reasonably obvious kind of sequence, right? We plan something, architect it, work with people, do some domain design, blah, blah, blah. And the goal of that planning is to allow them to build it better. And then once we build it, someone else runs it. So we, basically got architecture, software development, operations. Yeah? So I think that most software architecture, the last 30 years that I've been participating in it, is primarily about planning to build something. We are designing systems for developers so that they can understand what they're supposed to be doing, how the system should behave, and also we're trying to help them understand how to make this system mutable, secure, scalable, all these other things. That's primarily because we care about their ability to build, rebuild, and modify the systems. And this is a very functional view of the system. It's heavy on that purpose thing. Today, I want to talk to you guys about this, which I think is something that's less talked about. How do we architect for run? What would operational architecture be like? How should we think about it? So let's do some weird design theory first. So this is what's called a double pendulum. And the reason I'm showing you guys a double pendulum is because a single pendulum is pretty predictable. It will draw a straight line or curved line of roughly the same distance, and the pendulum end will be found in that straight line, or like slightly curved line, very predictably. And often we can think of that as being a simple system. And most people think of that as being a system that's very predictable. This is a chaotic system. And in this case, what we mean by chaotic is that if we want to know where the end point of the double pendulum will be at any one moment, it's very hard to predict in advance. It's not entirely true, because there's actually a fluctuation in the unpredictability of the second pendulum. It doesn't stay, it's not a steady uncertainty, but there is a large amount of uncertainty. The point here is this. That is what we call phase space. What a phase space means is that we can understand the pendulum as being probabilistically within this phase space. It will be not outside of this phase space. It will be within this phase space. So at a certain level, when we look at chaotic systems, they are deterministic. They're probabilistically deterministic. In other words, they create a phase space. They don't create a specific endpoint. From these ideas, we can get to this rather odd way of thinking about a system, which is this. Systems emerge from the interaction between structure, function, and fluctuation. These three aspects are always linked in what we call a dissipative system. And in a dissipative system, if you remove things like fluctuation and instability, the system collapses. It no longer works. I would like to kind of suggest that what we're doing when we design architecture, we get confused if we think we're designing at a particular endpoint. What we're actually designing is a phase space of possibility for what the people who are going to consume our software or our platform are doing. We're not designing an end state. So, there's some reasons for that, and I think the implications are interesting. And the first reason that I usually use to explain this is it's called the problem of future knowledge. If you think of the phase space as being a set of potential options for the use of some API or whatever you want to be thinking about, the more you constrain the phase space, the less options there are. In essence, it means that you're making predictions about what will be likely to happen in the future. And the question ends up being, how will you know, and can you know what's going to happen in the future? Because I believe design is evaluated in use and not during the design process itself, I think that the meaning and purpose of the system emerges only in use, And that is because the system itself generates knowledge, and that knowledge recursively changes the system. This knowledge is often represented as propositions in traditional design and architecture, and propositional logic is very causal. It says this, if this, then that, yeah? And so most of the time when we're trying to convince people of things, we're making a specific propositional line. I think that design needs to primarily consider itself instead as an aerotetic process. You have to be careful how you say that. And what an aerotetic process is about is it's the logic of questions. It's not the logic of answers. And so roughly what this is saying is that there is some set of presuppositions that you have. And that set of presuppositions makes an area of inquiry possible. And the area of inquiry makes certain questions valid or not. And then the answers validate the questions, and the answers change the presuppositions. The difference here is that questions are open-ended in that same sort of open-ended design point that I was trying to make earlier. So if we think of an architecture as being a set of propositions that we don't inherently know the answer to at the beginning, but instead we're putting forth a set of proposals, then we start to think through the idea that the design process is this inherently open-ended, inherently incomplete process that we're continuously involved in. This creates an idea that I call contingent contingencies. And so in most kind of theories of kind of randomness or probability, we only have a single level of contingency. There's a certain probability, and we're trying to make a decision about that certain probability. In human systems, though, because the systems are only propositions and not attempts to create specific end states, it creates a contingent that other decisions are made on top of. Those other decisions are also contingent, so we have a system of contingent contingencies. The result of this is that design is more or less persistent propositions concerning what could be. So you get this balance here about the more or less. It means that when we make decisions as designers, one of the things we're trying to do is decide how persistent we want to be with that particular proposition. It's not about having an answer, it's about how much we want to stabilize the system around a certain set of questions. So, Rescher also kind of says that this balance can be thought of as being a guess, and the more confident you are in your guesses, in other words, the more you constrain the system because you believe in the guesses, kind of the more brittle the system becomes. But also on the other extreme, the less accurate or specific you are, in my mind, the less likely you are to create an attractor that will enable people to begin using the system, which will stabilize it. So you get this weird version of the future knowledge problem, which is that the way to bet against future knowledge is to be less accurate in your predictions, but the less accurate or detailed the predictions are, the harder it will be for people to understand what the system is and how to use it. So it loses its effect as an attractor. So, hopefully by this part, convinced you that there are no closed systems. Closed systems are not possible. Therefore, a lot of systems thinking becomes difficult, traditional systems thinking. I hope that you have some understanding that in a complexity theory view, the closedness of systems theory has to do with the fact that you're trying to encapsulate everything in order to control it, yeah? And what I'm trying to propose here is you can't close it. You can only define where the boundary is and determine how that boundary enables interaction and therefore flows of energy through the systems. Therefore, boundaries, APIs, things like this, are attractors that engage people in the system, and that engagement is what causes the stability to occur. Hopefully you guys get the feel that I'm not into like telling people what to do with the API. So systems are about relationships. When we talk about systems, and I try to point out that this is what's called the theories of Mereology, the study of parts, the relationships between parts and wholes. And there's some obvious ones up. It went forward one without me telling it to, sorry. Oh, there's these timings in the slides, I hate this. Damn it. Give me 2 seconds. I have to take the timings out at some point. There's parts and wholes, which normally we refer to as bottom up. So the part makes the whole. Then there's whole parts. That means the whole and part relationships, tops down. And then there's whole part relationships, so the idea that there's peers. So like people tend to think of themselves as being whole and in peer relationships. So this proposition theory that I'm trying to point out results in this idea, which Alicia Giroux, oh my God. Alicia refers to as mereological recursion. And so the idea of mereological recursion is just this. You put some things together, that's your proposition. You put it into an environment, and if the thing that you put into the environment attracts other people, other organisms, other things to interact with it, you will create top-down constraints. The top-down constraints are the other things that are interacting with it. I cannot believe it's going to do this to me over and over again. Therefore, the system stabilizes in use. The whole comes into existence as a set of top-down forces only after it exists as a bottom-up or a parts getting together relationship, yeah? So whole to part or top-down constraints are restrictive. That means the parts are no longer independent, isolated particles, and they become components of a coherent unity and are thus blah, blah. I'm not going to go back anymore. I can't take it. Oh, it went back that time. All right. So whereas part to whole, bottom-up constraints are enabling, and when they close, a new phase space occurs, right? So this phase space thing I was talking about is the idea that we put some stuff together, we put it in an environment. If people start using it, the use of it stabilizes it, and then the stabilization of it opens up more possibilities for how it's going to be used. Make sense? It's kind of like an interesting recursive problem. So the result of this is that my slides won't go forward anymore. Lord Almighty. New wholes become potential parts with which to create new phase spaces out of new potential wholes. The newly formed hierarchical organization, which she refers to as an emergent holon, generates boundary conditions that maintain and stabilize its use. Again, the boundary conditions here are determined by use, not prior to use, and the network functions as a top-down or whole-to-part second-order contextual constraint, which means that it puts force on the components to stabilize them and keep them in that relationship. Roughly what that's saying, right, is that the more people that use, for instance, your API, the more stable the API will become, because you'll have multiple pressures on it, yeah? So, there is this other piece of this that I want to point out, because I don't want you guys to think it's all this like fluid thing that has no stability to it. Paul Cillier is an important complexity theorist, and he says there's a certain kind of slowness to systems. And partially what he means by that is if you're in an environment, the way you identify organisms in the environment is that they move slower than the environment does. That means that you can identify them because they're not completely responsive to the environment. If they were completely responsive to the environment, they would be reacting to everything happening in the environment, and it would be very hard to say that's a thing, right? So in other words, systems, what we refer to or think of as systems, are things that move slower than the context that they find themselves in. Another way of saying that is systems are sets of commitments. The commitments stabilize the system in relationship to an environment that's in flux. One of the main aims of instrumental rationality coming out of Enlightenment, therefore, was to try to stabilize the environment so that you could predict further and further into the future. The modernist project is largely about universalizing and normalizing the world in a way that it becomes more stable. You all can make your own judgments on how well that project's going. So an important part of complex systems is understanding that they have a history. And so that means their slowness kind of causes their own self-generation in time. They have a past and future, which are not interchangeable. And this means that human intentions flow into systems where we want them to do things, and that creates a history. It's not a complete random walk, but it's also not completely deterministic. It's a kind of a halfway point. In many respects, this means the system has memory, but the system cannot reflect or act upon everything which is going on in the environment at any given moment, because otherwise it would, again, lose its identity in the environment, and therefore something he calls hysteris is required. So, I refer to these ideas in design as the concept of hyper-temporal materiality. And what I mean by that is everything is a process. There is no such thing as matter. Matter is the way in which humans notice that certain things are moving slower than they expect them to be. In other words, there's differences in the rate of change in systems, and so what matters is when the system that you're working with won't change as fast as you'd like it to. Does that make sense to everybody? So what comes forward and what you ask questions about are the things that someone makes a commitment about, which slows the moving of the system down and forces you to notice and do something about it. So I think a good example of this is the debt metaphor. Does everybody know what I mean by the debt metaphor, the technical debt metaphor? The technical debt metaphor basically argues that you have a mental model, you have some idea in your head, you write software, you write some code. The code creates relationships with itself and other systems that it is related to. So it's no longer just related to ideas in your head, it's related to other structures in the environment. And therefore, if you change your mind, which you very frequently do because you learn by using the thing that you created, you learn how the design works in use, not prior to use, all of a sudden, the system appears to be making decisions for you, and often the system makes decisions that you don't want it to for you. And so we get this idea that the tech debt metaphor is a decentering of human agency, and it posits a way in which the code has agency, or the material systems that you're in shape your decisions and mold the conceptions you have of it as you interact with it. Again, that's because what matters only comes forth when you notice that it's not moving as fast as you want it to. It's kind of like friction. So, hopefully that's a bunch of design theory that helps you guys think about staying engaged in and moving through designs, and the idea that design is never something you can do for someone and then leave. You have to do it with them, and you have to do it with the system that is under design. You can't do it in abstraction. I want to talk to you guys about this other idea really quickly, which is what I call the three economies. So, what is a commons? A commons is a set of, or a pool of shared resources. The pool of resources that are shared amongst people has this quality, and they call the quality subtractability. And you'll notice again there's a temporal theme here. The way something is subtractable is that the resource is reproduced and the rate of consumption can exceed the rate of reproduction. And when that happens, there's a degradation of the resource. And therefore, if you are a member of a community that's consuming that part of the commons, the resource that you share will lose value. It will degrade. So why is this something I'm interested in? Commons have been said to occupy the space between privately held property and public goods. They're not only a resource system whose overexploitation leads to depletion, but commons also include communities using these resources and the social practices that define how the resources are used. Again, the resources here are not simply the material thing that we're pointing at, the grass in a field, but the use of them is part of what makes it a commons. If no one were using it at all, it wouldn't be a common resource. Commons aren't limited to resources like physical goods. Commons require commoning, which is an activity, which includes social practices, knowledge, shared spaces for working together, and active forms of governance. Commons emerge from interacting between locally and contextually bound concerns and global rationalities. You shouldn't hear the word global there as literally being of the globe, but just there's relationships between parts and wholes, and that's what causes the commons to emerge. So what's the problem? Like, why do I want to talk to you guys about this? There is a traditional way of viewing the commons. It's called the tragedy of the commons. I always have to put a caveat on telling people about this. The man who wrote this was a virulent racist who believed that the commons was the US healthcare system, and the tragedy of the commons was a bunch of Mexicans were going to come up and use up all of our tax resources. So the whole theory is based in a bunch of silly racism, but it has become a common thing that people talk about outside of that. So how do we define it? We've got a field, we've got a bunch of cows. We're a community where everybody has a couple cows, and we share the field. We all put our cows on the field, they eat a little bit of grass, we take them home, blah, blah, blah. Unfortunately, we have one member of the community who figures out, through a simple set of game theoretics, that there are two outcomes to them abusing the commons. In other words, putting more cows on the commons. The first one is that everyone will continue their current behavior, the pasture will be destroyed, everyone will lose their cows, including him or her, but that means everybody loses the same amount. So it's a zero-sum game. He doesn't lose anything. On the other hand, if he starts using the commons excessively, puts more cows than everybody else has on there, and everybody else backs off because they don't want to destroy the commons, they gain, they have more cows than everybody else, they win. This causes what is called the tragedy of the commons. And the interesting solution that people have had to this for years, and one that I think is common in many different communities, is enclosure. Enclosure is just creating boundaries and then giving people responsibility for what's inside the boundaries. And the belief here is that that will assign responsibility to particular people for particular resources, and that will maximize the good for the community. Sounds good, I guess. But I think it causes what I call the tragedy of enclosure. The tragedy of enclosure is that local needs are erased. That means that the owner doesn't have to care what the people who used to be using the commons want. Private concerns, the owner's concerns, destroy common concerns. The practices of self-governance are lost. In other words, you remember I told you that commons comes with a process, an activity, a community that has to practice a certain form of governance. When the commons is lost, you no longer have a space to practice that form of self-governance. And the rationality and data are narrowed primarily to appeal to the owner, and that which gains in value by being a common is destroyed because it's not needed anymore, the common, according to the owner. All right, Jabe, you've been ranting. What does this have to do with enterprise IT? Does this sound familiar? There's a bunch of teams in your firm that are rewarded for accelerating differentiation of customer value. In other words, they're rewarded for either differentiating your product against your competitors or for creating new products to capture new markets or new market niches to address new customers. On the other hand, there's another group of people in your organization that are rewarded for operational excellence and creating efficiency. This seems to cause a paradox. And the paradox seems to be that one side wants to increase variety and the other side wants to decrease variety. In most firms that I work with, when I first get there, they only have two economic theories, two governing theories, two games that are being played. They have one side that might be called the business line, the product line, the business unit, or the agile feature teams. And those people highly value autonomy, agility, ownership. And they have another group that's called central IT. And those people are responsible for and value things like change control, approved architectures, reference architectures, procurement control, control of availability of resources, resource constraints, and capacity planning. They are rewarded and they win their games in different ways. One side wins by getting more customers, entering new markets, and doing things differently. The other side wins by controlling consumption, using best practices, and doing the same things repeatedly. One side tries to maximize the ability to respond to local variation and adapt to environmental pressures. The other side tries to maximize the ability to harvest value from owned assets like hardware and the predictable nature of commodity goods. Moore's law is pretty predictable. You should be able to figure out how many CPUs or how much network you need and plan for that. You should be rewarded for doing that planning well. We're going to call these two economies, these two games, the economy of differentiation and the economy of scale. One side relies on consumable, publicly held resources. That's the things that the central IT department provides them. And the other side governs the consumption of those publicly held resources. Great. We have two sides of the organization that want to achieve different things, but they're interdependent. We have a paradox that we have to resolve. I assume most people recognize this paradox and have had some experience with the conflict that I'm talking about in their organization. It seems incredibly common. So is there a way to get out of this paradox? Is there a way to think about this? Is there maybe another game that we could play? So the trick for figuring our way out of this paradox and understanding what we might want to put on a platform is to understand this trick. The tragedy of commons applies to things that have a quality of subtractability, yeah? Subtractability is essentially consumption and the degradation of systems in consumption. I think in IT, these things are pretty obvious. If you don't control access to your network, the network can be overconsumed. If you don't control access to your storage, the storage can be overconsumed, et cetera, et cetera. Therefore, central IT and governance of resources that can be consumed continues to be important still. Because if you don't manage these things and control access to them, they will cause problems in the organization. On the other hand, there is a vast amount of things in your environment, in your firms, that could be consumed by more people, but don't lose value, but instead gain value in consumption. So, common data structures, well-factored functions, patterns of configuration, patterns, architectural patterns, etc. The result is we get this three economy theory. There's an economy of differentiation, there's what's called a scope economy, and there's a scale economy. The weird little Y there is an indication of the investment of complexity or variation across the system. Variation is highly valuable in the area where we're concerned about differentiation. Variation is highly undesirable in scale. The scope economy, or a platform, is essentially a clutch between these two parts of the organization that allows a group in the organization to make promises to the scale economy about predictable planning and consumption, and on the other side, to make promises about accelerating differentiation and change. That is what I believe a platform should do. So a scope economy or a platform team should be primarily responsible for accelerating the adoption of shared resources that do not degrade in use, and doing so by fulfilling promises that allow the scale side to create resilience and the differentiation side to accelerate productions of difference. So what is ReCommoning? This activity that I'm talking about is what I think of as platforming or ReCommoning, and it simply says this: if you go back to your firm and you believe my theory that I've presented, you will go back there and determine that there's only two economic theories in play: theory of differentiation, theory of scale, and you will be able to look through the teams that are doing differentiation and find teams in that part of the organization who either have resources that would be more valuable if they were shared, and or that are sharing resources themselves with other teams, which is distracting them and their product owners from serving their customers. And so those things could be moved onto a platform. On the other hand, you'll go back and you will find a series of things inside your central IT department, and those things will be currently being throttled. People will be having a hard time using them because the central IT department believes their job is to control consumption. That is a bad economic theory for platforms. Platforms should not try to control consumption. Platforms should accelerate consumption. So that will be a list of things that you can move. So, platforms may be understood more conceptually as guiding principle that defines two sides of a binary relationship. That's your differentiation and your scale. And it reveals a middle mass. That middle mass is the scope economy as an opportunity for intervention. Platforms can help us recommon resource management through new approaches to negotiation. Understanding the nature of the resources in relationship to consumability and reproducibility and differentiation, determining the appropriate economic rationalities for optimizing the value based on the nature of those resources, and establishing governance and social practices to enable the transition from one economic theory to another. This is the activity that I believe is actually what we need to learn how to do in organizations if we're going to do platforming well. And I will point out that this idea of sharing, while somewhat played within teams, is very rare in my experience, in organizations. Most organizations don't know how to share resources across teams, and that's primarily, again, because their two rationalities, current rationalities, are both rationalities of enclosure and responsibility. If you want to read more about kind of this stuff, this book is great. I suggest it. It's about the open source movement. This is my professor, and he points this one thing out that I love, which is a platform is a place to work together. And we need to kind of keep that in mind. It's not a service that we provide to others. It's a place where we come to work together on a common thing. So in this way, I have questions about how we can think through what open source can teach us about ReCommoning and platforming, and I think that is a question we should explore more. So, last rant. I think I have time. I believe that one of the problems we have right now in many communities is this idea of value streams. I love value streams. I'm not saying that's a bad idea. But what I am saying is that people tend to think of value streams as being towards production. And therefore, they think of value streams as like somebody has an idea and it goes through some processes and then it goes to something like a platform team and then it goes to something like an infrastructure team. And they try to make these systems kind of single value streams that cut across like that. I think that, in fact, all three of these things are value streams. What happens is that the higher level value streams happen to consume the output of the lower level value streams. And that means that each layer here is software that requires both development and operation. So, I think we see these movements towards self-service, towards appropriate enabling constraints, and removing of complexity from infrastructure. I think we're best right now at the removal of complexity from infrastructure. I think we're getting better at the top, providing self-service access, but I still think that we're having a very difficult time with the enabling constraints. So, this is all software. And we need to treat it as software. Yep, all software. Everybody's trying to deliver a SaaS. They haven't yet figured out how to build a PaaS which is reliant on an infrastructure as a service. Additionally, everybody has a software development lifecycle. Very few people have a platform development lifecycle or an infrastructure development lifecycle. So my proposal to this community in particular is that there's work to be done. And the work to be done is this. When we design platforms, we need the domain experts designing the platform to be operators and developers. We should do domain-driven design, but we should call the consumers of the platform in. And the consumers are not just the developers, they're also the operators. And we should help them understand how to shape the API that they need to get access to things like platforms and infrastructure. For a long time, people have been saying that these things should be developed as APIs, but in my experience, very few people are actually developing APIs. This is partially, I'll partially point out what I mean by this really quickly so it's a little bit clearer. I think in many places, the APIs are primarily functional. Give me this. But in very few places is there an API where the operations team can explain to the platform team, so the application operations team should be able to use an API to tell the platform team what healthy looks like. My application is healthy if it's doing these things. And therefore, instead, we get all these people kind of creating SLOs and other things, other ideas, and kind of transferring them via paper to each other, building dashboards over there. But that all, I believe, instead should be done via API. Therefore, what we need to be doing is building first-class interfaces for operators as well as developers. Particularly in the platform engineering community right now, I'm very concerned that operations is essentially being erased. And this is partially because of I think, a significant confusion over this Vogel's quote. So Vogel wrote this about 3 years before anyone ever said the word DevOps. And it's the you build it, you run it theory. And I think the thing that people need to hear in this quote is, we have services at Amazon, and if you choose not to use the services we offer from our platform, you build it, you run it. Different than saying, everything that you build, you have to run the full stack. Yeah? And so the idea here from Vogel's was to put pressure on teams to not build things that weren't specific to their needs, their own needs, and to consume common shared resources and lower their own operational burden by putting the operational burden in the right part of the organization. I think all of this can be summarized as the need to understand socio-technical architecture better, where the socio parts have to do with all these ideas I was talking about, propositions, design risk in use as opposed to design risk happening during the design process itself. Being able to create an architecture that can fulfill promises because the analysis has been done to make sure the technical problems have been solved. And those promises creating the components that allow for that phase space that we talked about for the social world to explore. I think that this is partially about expanding the conversation that we've been seeing for the last 14 years in the DevOps community, and by starting to include product management and architecture in that conversation. If you have an organization, often I find, you probably have a product roadmap, and you probably have a technical roadmap or an architecture roadmap. And I'm shocked by the number of times I've said to people, have your product managers looked at the technical roadmap? And have your architects design the technical roadmap based on the product roadmap? Or did you go into separate rooms and make up things without talking to each other? I think these conversations are critical for us to move forward with, especially platforming, which requires larger investments and larger time cycles, and is much closer to the practice of architecture than the practice of development and operations. And I think that we can start seeing some of those conversations might be named things like product architecture, product operations, architecture development, the ability to develop your own architecture or platform, architecture operations, operations architecture, operations as a product, development architecture, and development as a product. So my last couple slides. I am the Lorax and I speak for the ops. Unless someone like you cares a whole awful lot, nothing's going to get better, it's not. We need to include our operations concerns as first-class citizens when we're doing architecture. We need to design our systems to be operable, not just functional. We need to begin to develop and design and architect systems to be in operation, not simply to be functional. I believe one of the ways to start thinking about that is to move beyond the concept of socio-technical systems and start thinking of the idea of technology as being a way of skillfully coping with ecological concerns. Your componentry, your various pieces that people are putting together in your systems are ecologies. And the technology, or the techne, is the ability for your firm to wrestle with those things and get them into particular shapes. If you liked my talk, I am doing a podcast very regularly. I've got some of my friends on the screen that have even spoken here. We like to talk about platform architecture, and I hope you'll join us. Thank you so much.